The principle of superposition is just that waves, when they occupy the same space, they superpose. That's another way of saying that they just add together. An example of this is if two people talk, you hear both people talking, and sometimes you can't understand it, right? If you shine a flashlight across the room, the flashlight beam doesn't cast a shadow. The lights from the top of the room can shine right through the beam of light shining across the room, right? Ripples in a pond. So if you throw two stones in a pond, you'll get this cool overlapping pattern. Now notice that there's like some places where there's hardly any wave and places where there's a lot of wave. More on that in a second here, right? Okay. There's two different types of interference or whatever when they add together. The first is called destructive interference. So in this case, an up pulse and a down pulse. And this works with sound as well. Okay, where they overlap, you get like a nothing, right? For an instant, of course, the medium is moving here, so all the energy turned into what, I guess, kinetic energy, right? This stuff's moving this way, this stuff's moving this way, right? And then the waves pass right through each other, okay? So this is destructive interference. Constructive interference is when they make a bigger pulse like this, right? So an up pulse and an up pulse creates a huge up pulse, okay? Now, I just have to show you this demonstration here. This is the most awesome thing. Wait, is it this? No, it's this one. Okay, watch this. This is great. It's got good music, too. We're going to do this. I feel like we need to. So that's constructive interference. Here they're going to show you destructive interference. So it knocks those cups out of the way, but it goes right between those. That's fun, huh? All right, let's go back to here. All right, so the first thing you saw was actually this constructive interference, and then you saw the wave pass right between the cups and not knock them out of the way, right? We have to do this. We have to do this. This looks like too much fun. Okay. Now, there are some rules, and obviously we need to get to, some problem we can solve with this, right? So this is the basic idea, right, is that destructive interference, constructive is when crest meets crest and trough meets trough, right? Destructive interference is when crest meets trough or trough meets crest, right? Okay, so let me just show you an example of this. Here we've got crest meeting crest, a trough meeting a trough. So we get a super crest and a super trough. We don't get a super tramp though. That's a music group from the 70s and 80s. Anyway, notice here, this is destructive interference. So this is constructive, right? This is destructive interference, right? And this is a crest meets a trough. And here we've got a crest here meeting a trough there, and a crest on the top meeting a trough on the bottom. If you added these two waves together, you'd get nothing. Okay. Now imagine that this is a wave made by the ambient noise, right? Imagine that this is a wave made by your headphones that you're wearing. This is what you hear, right? So when you're looking at those Bose noise canceling, I think they were the first ones to come out with it, the noise canceling headphones. That's what they're doing, is they got a little microprocessor that hears the ambient noise coming, generates the opposite of that, and those two intersect where your ear is, and you hear nothing. Okay. Now, there are some rules for constructive and destructive interference, and it has to do with the shift of these waves. Okay, so let's look at that. If the difference in distance from the sources is, let's say you have two sources of sound, right? And one is here and one is here, and you're maybe here. Okay, you're going to be a different distance from one source than you are from another. Okay, if it's an even number of wavelengths, you get constructive interference. Let me show you this. This is 0 wavelengths difference, right? This one is 1 wavelength. We move this guy over 1 wavelength, and this is 2 wavelengths, right? So if the difference in distance is an integer number of wavelengths, so 0 wavelengths, 1 wavelength, 2 wavelengths, if it's in whole wavelength, then you still have crest meeting crest and trough meeting trough, so you get constructive interference, okay? On the other hand, if you have a half wavelength, whoops, what did I just do? I have no idea. Okay, if you have a half wavelength difference, now I'm going to show you this. I can actually show you this with a couple speakers. You can move them half wavelengths, whole wavelengths. It's the coolest thing in the world. We'll make anti-sound in the laboratory. Okay. But anyway, notice that I've shifted B a half a wavelength. This is a whole wavelength, right? I've shifted it 1/2 wavelength. Okay, so this is 1/2 wavelength, right? This is 1.5 wavelengths. This is 2.5 wavelengths, right? So basically the math for this is if it's n plus 1/2 times lambda, where n is 0, 1, 2, 3, right? Then it's destructive interference, okay? All right, in the next video, I'm gonna show you how to actually do calculations with this.